Oh, am I recording? All right, here we go. So welcome back to 3.7. This is equations of lines. We're doing part 2 today, and this is the most important equation you'll ever learn. In my opinion, it's better than slope-intercept form. It is point-slope form. Now, in slope-intercept form, the two key ingredients were it had a slope and it had a y-intercept. That's why it's called slope-intercept form. The key ingredients for this guy are that it has a point, it contains a point, and it has a slope. So it's a little bit similar. Technically, a y-intercept is a point, but we're going to show how it's so useful here. So it's two key ingredients, okay? We already talked about this, the slope, and that's represented by m, and m is listed here. That's the slope. And then we also have this. This is the given point. The given point, there has to be a given point with point-slope form, and we label it x1, y1, okay? Not to get it confused with x and y. That's why we label it with the 1. Because your x and y are still your inputs. We still have the x, we still have the y by itself that needs to remain untouched because those are our inputs. Those are the things that changes, that gives us an infinite number of solutions. So don't touch the x and the y. The only thing that we mess around with are the x1 and the y1. Okay. How do we graph this? Well, let's take, for example, where am I? Okay, so we have this example. We have y minus 2 equals negative 2 times x plus 1. Okay, so if we were given this equation, we'd first have to identify everything. Well, as you can see clearly here, this is our m, because this is the number that's in front of the parentheses containing x and x1. This would be our x1 right here, but it's a little tricky. I'm going to show you why. And then this would be our y1. Okay, so this is kind of a little dark, but you get the point. Okay, so I'm actually going to erase this because I can barely see my x1. Okay, now, a lot of people would say, oh, my x1 is 1, my y1 is negative 2, and then my slope is negative 2. No, 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 no. Okay, I'll agree with you on one thing, or two things. No, just one thing. Our slope is negative 2, okay? We see that, negative 2, that's our slope. Slope equals negative 2. That's one thing you got right. Okay, that's our m, however you want to say it. Now, here's the deal, is let's start with the y. It's y minus y1. So we have y minus, our y1 is just going to be this guy right here. y1 equals positive 2. This is the one tricky thing about point-slope form that confuses students, is that it's y minus the value, okay? So what does that mean for our buddy x over here? Well, we don't have a minus sign, so where'd it go? Technically, this could be rewritten as x minus a negative 1, because if you subtract a negative, it turns into a positive. So what is our x1 here? Our x1 equals negative 1. A way to think of it is our x1 and y1 are the opposite of what's shown in the form. So if we see minus 2, we know it's a y1 equals 2. If we see x plus 1, we know it's the opposite. We know our x1 is negative 1. So it's a little tricky there. Because the general form contains the minus already, we have to account for that. All right. So now that we have our x1, y1, and our slope all set, we're essentially good to go. So step 1, we are going to plot the given point. Okay, in this case, it's our x1 and our y1. So kind of the pre-step is to make sure that we identify what is our x1 and y1. So make sure you, I'll put this as a star, identify identify m, x1, and y1. Make sure you do that first. Okay. So we plot the given point, x1, y1. So we already identified our x1, y1. So if we were to write this as a point, it would be what? Well, I shouldn't put it there. That's right in the middle of my graph. What am I doing? Let's put it here. So my x1, I already said, is negative 1, and I already said my y1 is 2. So I'm going to go to the point negative 1, 2. Wow, look at this graph. Very accurate here. Look, everything's spaced out so perfectly. Awesome graph. Wonder who did this. Okay, so negative 1, 2 is my first point. Now, what am I going to do next? I'm going to use slope. This is just like slope-intercept form. I'm going to use my slope to find additional point, or plot additional point. And technically, you could keep doing it. You could do this multiple times. That's why I'm going to put plural points. So now I got to go, where am I going? I got to go use my slope. My slope is -2. How do I know what my rise and run is for -2? What's my rise? Oh, that's my, yeah, there's my slope. There's my rise, and this is my run. What's my rise and run when it's expressed this way? Well, I can always just put it over 1 to make it into a fraction. And now I know my rise is -2, and I know my run is +1. Okay, so I'm going to go down 2 units from this point, the given point. So I go down 2 units, and then I'm going to go right 1 unit. I'm going to make another dot. I'm going to make it green just to show that's the second point. And then how do I finish? I connect the dots. Okay, this is just like slope-intercept form. If you want to review that from the first video, and there you go. Okay, so that's my point-slope form. Now, something cool about point-slope form, okay, one thing you'll notice is it doesn't give us the y-intercept in the equation. So in our equation, y minus 2 equals -2 times x plus 1, it doesn't tell us what our y-intercept is. Now, we can find it by converting into slope-intercept form. So what was it? Y minus 2 equals -2 times x plus 1. If we want to convert to slope-intercept form, converting to y equals mx plus b, all we need to do is solve for y. Okay, so what we're going to do is we just have to get the y by itself. So what we're going to do, if I say that one more time, I swear, we're going to take y minus 2, okay, and we are going to, let me use orange. We're going to add 2 to both sides. Well, first, actually, we should distribute. But then we are going to add 2 to both sides. So we're going to distribute here. We get -2x minus 2, y minus 2. And then we're going to add 2 to both sides. Add 2 to both sides. We get y equals -2x. -2 plus 2 is 0. I can put plus 0, or I can just write y equals -2x. So that's it in slope-intercept form. And as you can see from this, my y-intercept is 0. Well, look where my graph was for my point-slope form. My y-intercept was also 0. So it's the same thing. This and this are the same thing. They're just expressed a little bit differently, and they're used for different purposes. In my opinion, point-slope form is a little bit more useful in terms of overall practicality. Slope-intercept form, you know, it's good for certain things too, but point-slope form is really where it's at. I'm hoping to make believers out of you eventually. Okay, so we get some practice here with slope-intercept form and also point-slope form. First, this one is in slope-intercept form. How do I know? Because the y is by itself. So let me get the purple. So we have y by itself, and this is slope-intercept. Okay, so I have to, for slope-intercept, I have to identify my y-intercept. In this case, it's -5. So I'm going to start there with this orange guy. Orange. So 1, 2, 3, 4, 5, -5. And then my slope is this guy, 1 over 5. So 1 over 5, my rise is going to be 1, and my run is going to be 5. So I rise 1, okay, so I rise 1 from the y-intercept, and then I run 5. 1, 2, 3, 4, 5. So right here should be my second point for the orange guy. 1, 2, 3, 4, 5. There he is. Something like that. I kind of missed, but I hope you get the point. And then I connect the lines, or the dots. Please forgive me. All right. Now, the next one is in point-slope form, so I have to do a little bit of work here. I have to identify my slope. Got it. If you want, I would put this over 1, so you know what your rise and run is. Rise of 4, run of 1. Okay. Now I have to identify my x1 and y1. My x1 and, whoops, I did that backwards, didn't I? y1 and then x1. And that's going to be my point. So my x1, Okay, think the opposite. This is really x minus a negative 1. So my x1 is negative 1. And my y1 is really y minus a negative 3. So it's really negative 3. So that's my x1 and y1 for the green guy. Now, how do I graph the green guy? Well, I start at my given point, negative 1, negative 3. I make a dot, and now I use my slope. Up 4, 1, 2, 3, 4, and over 1. My rise and run, and there I go. Got my next graph. Okay, and this line, we need arrows on either side so we can show that it has an infinite number of solutions that make that true. Okay, one more to go. I'm going to show off this. This is a drawing by Isa Costa. She's in my geometry class. Awesome pumpkin. Really love it. Pumpkins are great. Jack-o'-lanterns are great, but great artwork. Feel free to send me some artwork, and I'll try to put it in the next video. So here we have y plus 1 equals negative 3 over 2, and then x minus 2. Okay, what do I do here? Well, this is obviously in point slope form. I need to identify my slope. There it is. It's negative 3 over 2. The top number is going to be the rise, and then we have my run. Okay, and now I have to identify my x1. I always do it backwards. And my y1. Okay, so that's going to be my point. So what is my point? Well, I have x minus 2, so it's a positive 2 for my x, but here I have plus 1, so that's really an x, a y1, y minus a negative 1, so negative 1 is going to be my y1. So I'm going to go to the point 2, negative 1 for my blue guy. 2, negative 1, I start there. There's my first point, and I'm going to use my slope, which is negative 3 over 2. So I'm going to go down 3 units, 1, 2, 3. And to the right 2 units, 1, 2, make a point. Okay, and then I connect my line. That was an utter fail. Well, you know what? Try again, right? Why is it doing that? There, finally. It just was lifting up, I guess, and with my arrows. So we got this little cool shape here. Happy Halloween. I hope you guys enjoyed this video, and stay tuned for next time when we talk about perpendicular and parallel lines. Thanks for watching.